Now we're going to calculate the Sharpe ratio for our portfolio. It's the slope of the CAL or capital allocation line. The Sharpe ratio is simply the expected return on the portfolio minus the risk-free rate divided by the standard deviation of the portfolio. Gives you a risk-adjusted measure of return. All else equal, you would prefer a higher Sharpe ratio to a smaller Sharpe ratio. So optimal risky portfolio is the best combination of risky and safe assets to form a portfolio. We calculate the optimal risky portfolio by for two risky assets by using this formula. We take the weighted bonds, and to calculate the weighted bonds, it's the expected return on bonds minus the risk-free rate. Multiply that by the variance for stocks, subtract the expected return on stocks minus the risk-free rate. We multiply that by the standard deviation for bonds, standard deviation for stocks. Multiply that by the correlation coefficient for bonds and stocks. Recall that these three items also are equal to the covariance for bonds and stocks. That number will repeat itself down here. So we divide that by the expected return on bonds minus the risk-free rate, multiplied by the variance for stocks plus the expected return on stocks minus the risk-free rate. Multiply that by the variance for bonds, subtract expected return on bonds minus the risk-free rate plus the expected return on stocks minus the risk-free rate, and we multiply that again by the covariance or standard deviation for bonds multiplied by the standard deviation for stocks multiplied by the correlation coefficient for bonds and stocks. And so once we've calculated the weight for bonds, we just subtract that number from 1, and that'll give us the weight for stocks. That gives us our weights for our optimal portfolio. We saw previously the minimum variance portfolio. For the minimum variance portfolio, the weight in bonds is typically the variance for stocks minus the covariance for stocks and bonds, or the correlation coefficient for stocks and bonds multiplied by the standard deviation for stocks and the standard deviation for bonds, and all of that divided by the variance for stocks plus the variance for bonds minus 2 times the covariance for stocks and bonds, or 2 times the correlation coefficient multiplied by the standard deviation for stocks and the standard deviation for bonds. And again, same idea. Once we've calculated the weight for bonds, we just subtract 1 from that, and we can calculate the weight that we're going to invest in stocks. We created our investment opportunity set here and previously, so same idea. This chart shows our minimum variance portfolio. We have bonds here, stocks here. Just an example portfolio here, A. So this portfolio appears to have an expected return around 6 and a standard deviation of 8. Going forward, we can see that our optimal portfolio, which is the point where the capital allocation line is tangent to the investment opportunity set. So here we'd have expected return of 7.16 and a standard deviation of 10.15. So this graph shows our the bonds, minimum variance portfolio, optimal portfolio, and stocks, and then our capital allocation line. So this formula is the one that we would use for calculating the weight in stocks and the weight in bonds for that optimal portfolio. So then we can, our complete portfolio simply here is we choose our asset allocation between the optimal portfolio and the risk-free assets. Anything beyond the optimal portfolio would involve investing on a margin, but in this case, the portfolio C looks to be somewhere in the neighborhood of 50-50, probably not quite, but expected return of 5.29% with a standard deviation of 5.58%. So, we would calculate the expected return would simply be the weight in risk-free asset multiplied by that weight times the weight in the optimal risky portfolio multiplied by that expected return, and the standard deviation would simply be the weight in the optimal risky portfolio multiplied by the expected return in the optimal risky portfolio. So this figure 6.8 is just the portfolio composition for this this portfolio C. So we've got 45% in T-bills, 31.24% in bonds, 23.76% in stocks.